So we're going to do another problem. Let's say we have a car accelerates at an initial speed of 8.9 meters per second, and it accelerates at a rate of 1.5 meters per second squared. And let's say in that time frame it travels 125 meters. What we need to know is this car's new speed. And note that in this particular problem, we don't know time. Like we've done in previous problems, let's start by identifying what we do know. We have an initial velocity of 8.9 meters per second. We have an acceleration of 1.5 meters per second squared, and we have a distance traveled of 125 meters. What we're being asked to find is the final velocity. First, I'm going to look at the three kinematic equations that we have already used. And what we'll see is that each of these equations have time somewhere in the equation. And since we don't know time in this problem, the first three kinematic equations will not work. So what we're going to do, just like we did on the third equation, we're going to combine the first two to make a better problem. The easiest way probably is to use our first two kinematic equations. I'm going to take our first equation and write this again in terms of time. So I'm going to have 2d divided by the velocities added together equals my time. And now what I'm going to do is I'm going to take this value and I'm going to substitute it in to that equation right there. So what I have is my final velocity is the initial velocity plus a times t. But we know that t is 2d divided by the sum of the velocities. I'm going to simplify this a little bit. So my final velocity equals my initial velocity plus 2ad over the sum of the velocities. Now, that equation is still a little bit complicated. So let's see if we can get rid of the denominator, the fraction looking thing here. So I'm going to move my vi to the other side of the equation. Vf, take away vi, equals 2ad divided by vi plus vf. And then if I multiply both sides by this, we'll see that we get rid of that denominator. So we have vf take away vi, which was already there, multiplied by the vi plus the vf, and that equals 2 times a times t. Well, now I've got the multiplication of a polynomial here. Okay, what I'm going to end up with, let's say I have a vf times a vi, so I'm going to end up with a vf times a vi. I have vf times a vf, that's going to give me a vf squared. I'm going to have a negative vi times a negative vi, so I'm going to end up with a negative vi. I'm going to have a negative vi times a positive vf, that's going to give me a negative vi vf equals 2ad. I'm sure you'll love your algebra. What you should see, I missed my squared right there. What you should see now is that we have a positive VFVI and a negative VFVI, so they are going to cancel each other out. And what I'm left with is VF squared take away VI squared equals 2AD. Usually this is simplified a little bit to say that the final velocity squared is the initial velocity squared plus 2AD. And this is our fourth kinematic equation that is frequently used. And then there's some variations of it I'll go over as well. Now I can use this fourth kinematic equation to solve my problem. So VF squared equals VI squared plus 2AD. Once again, we knew that our initial velocity was 8.9 meters per second. And we're going to square that. And to it, we're going to add 2 times the acceleration, an acceleration of 1.5. Going to put that in brackets, meters per second squared, multiplied by our distance, which was 125 meters. Once again, I want to point out that the units always have to work out when we're doing this. So when we take our 8.9 meters per second squared, what we're going to end up with here is 79.21 meters squared per second squared. Add to that 2 times 1.5, that's like saying 3. 3 times 125 is 375. Once again, we have meters times meters, which is meters squared over seconds squared. And you'll notice that my units work out very nicely. So now I'm going to add those two numbers together. And when I do, I'm going to end up with 454.21 meters squared per second squared. And don't forget, this is our final velocity squared. So to get our final answer, we will take the square root of both sides. Our final velocity will be the square root of this number. And watch this, the units meters squared per second squared. It's just going to give us meters per second, which is awesome. And we're going to end up with a square root of 254, which is approximately 21.3 meters per second. Now let's do a little bit of algebra to isolate the different variables in this fourth kinematic equation. The easy one for me is let's find what VI is. I'm just going to subtract 2AD from each side of my equation. So VI squared will be the final velocity squared, subtract 2AD. Another equation I could do is I could isolate either A or D. And they're both going to start the same. I'm going to take my final velocity squared, subtract my initial velocity squared to give me 2AD. And then what I'll do from here is I'll divide that equation, VF squared minus VI squared, divide that by 2A, that equals D. And if I take the same equation and divide it by 2D, that equals A. So now I have this fourth kinematic equation written in terms of VF, I've got it in terms of VI, I've got it in terms of D, and I've got it in terms with A isolated.